Hello, mathematicians. Today we're going to learn something called completing the square. So our first example says, what term must be added to x squared plus 10x to make it a perfect square trinomial? So what we are looking for is the term that would go right here to make this be a trinomial, but also a perfect square. And so to do this, what we do is we always take our first term, x squared, and we put it in our first box. And now we want this box to be a square. What is the difference between a square and a rectangle? The difference between a square and a rectangle is that in a square, all four sides are the same. So we're going to have to take this middle term of 10x and we are going to have to split it into two perfect pieces. Those two perfect pieces are going to go in these boxes right here. By splitting the 10x perfectly into two, then it will make it so that our box right here is a square instead of a rectangle. So what is 10x divided by 2? 5x. From here, we're going to find the GCF of each row and of each column. The greatest common factor of my top row is x. The greatest common factor of the left side is x. X times what number would give me a 5x here? 5. X times what number would give me a 5x here? 5. So now we can see that this side length is x plus 5, and this side length is x plus 5, making this shape a square, which is what we want because we are completing the square. Now, in order to complete the square, we need to complete this box right here. To find what this box is, we are going to multiply 5 by 5. What is 5 times 5? 25. So 25 is that missing number that completes the square. Then it says, write the factors as a perfect square binomial. Well, here we have a perfect square trinomial, x squared plus 10x plus 25. And we just factored this perfect square trinomial. When we factored it, we got x plus 5 times x plus 5. Well, I can rewrite x plus 5 times x plus 5 as x plus 5 squared. So this is the process of completing the square. Let's try that again on example 1. So our first step is to always take half of our b term. So half of our b term is, so half of 2x is 1x. So I'm going to have 1x here and 1x here. You also want to make sure that you take your first term and you put it in the first box. So now that we have this set up, we can go ahead and start factoring. The greatest common factor in my top row is x. The greatest common factor in my left column is x. X times what number would give me a 1x here? 1. X times what number would give me a 1x here? 1. So now we can find the missing number that completes the square by doing 1 times 1. And 1 times 1 is 1. So 1 is the missing number that completes the square. Well, we just factored x squared plus 2x plus 1. And we got x plus 1 times x plus 1. We can rewrite that as x plus 1 squared. Go ahead and pause this video and try example 2 on your own. On example 2, the first thing I'm going to do is I'm going to write the first term in the first box. I want this shape to be a square and not a rectangle. And in order for that to happen, I need to divide my middle term by 2. 4x divided by 2 is 2x. From here, I can find the GCF of each row and of each column. The greatest common factor on my top row is x. The greatest common factor on my left column is x. X times what number would give me a 2x here? 2. X times what number would give me a 2x here? 2. So now we can find the missing number that will complete this square. And we can do that by doing 2 times 2. 2 times 2 is 4. So 4 is that missing term that completes the square. We've now factored x squared plus 4x plus 4. And when we factored that, we got x plus 2 times x plus 2, which is the same thing as saying x plus 2 squared. Let's go ahead and look at example 3. On example 3, I'm going to take my first term and I'm going to put it in my first box. I want this shape to be a square and not a rectangle. In order for that to happen, I need to divide my middle term by 2. Negative 6x divided by 2 is negative 3x. Now I can go ahead and factor each row and column. The GCF of my top row is x. The GCF of my left column is x. X times what number would give me negative 3x? Negative 3. X times what number would give me a negative 3x? Negative 3. Now we can find that missing number that completes the square by multiplying negative 3 by negative 3. And when we do that, we get positive 9. Because a negative times a negative is a positive. So 9 is that missing term that completes the square. We have now factored x squared minus 6x plus 9. When we did that, we got x minus 3 times x minus 3, which is the same thing as saying x minus 3 squared. Go ahead and pause the video and try example 4. My first step on example 4 is going to be to write the first term in the first box. I want this shape to be a square and not a rectangle. In order for that to happen, I need to divide my middle term by 2. So negative 8x divided by 2 is negative 4x. Now I can go ahead and factor each row and each column. The GCF of my top row is x. The GCF of my left column is x. X times what number is negative 4x? Negative 4. X times what number is negative 4x? Negative 4. Now we can find that missing number that completes the square by multiplying negative 4 times negative 4. And when we do that, we get positive 16. So 16 is that missing term that completes the square. We have now factored x squared minus 8x plus 16, and we got x minus 4 times x minus 4, which is the same thing as saying x minus 4 squared.